Right, okay, so what we're going to do is start looking today at position vectors. Right, so position vectors are a way of describing them kind of from, instead of kind of doing the way that we write like the U, we can kind of work out a position vector by, that's the kind of donation of like A, B, like that kind of notation. Is a way of donating position vectors. And what that is meaning is the vector from A to B. Okay, so we can also do it in lots of other ways, right? So if I'm going to do it in 2 dimensions because it's hard to draw in 3, but it works with 3 dimensions as well. Right, so we've got this point P here. We could say that this vector there is the vector P, or we can do it in terms of kind of its position vector. So point P on this diagram has the coordinates of x, y. Okay, so what we're doing with our position vectors is saying, like, how far have I had to go to get from point O to point P in this diagram? So you can see in the x direction, I've had to go x along. So that vector O to P, I've had to go x along the x-axis, and then I've had to go kind of y along the y-axis. So it's x, y. Okay, and that's a way to do it when you've got it at the origin. But quite often what will happen is you'll be given the coordinates of those points, but there won't be one of them at the origin. You've kind of got to create that triangle yourself. So if we have now a line here, this time we're going to have the line A to B. Right? And then we've still got that line AB is still kind of in a coordinate system like this. Right? So to get this coordinate system, to get from A to B, we can go from A back to the origin. Yeah? So that would be A to O, or kind of minus A, because we're going in the opposite direction. A is going like towards it. Yeah, so we're going kind of back the way, and then we're going out to B. Yeah? So that's saying the vector AB is equal to minus A plus B. Yeah? So we can kind of rearrange that to say that it's B, take away A. Okay, so this works for any vector at all, is that we can find the position vector using the coordinate system by assuming that we're going back to the origin each time. So as you can see, like from the first diagram, if we're looking from the origin to a point, our vector just becomes those points, doesn't it? Like the x-coordinate becomes the top of our column vector, and the y-coordinate becomes the bottom of our column vector. And if we had a z, it would be the third part. So that's why here we can go from O to A is the same as vector A, but because we're going in the opposite direction, we've got to make it negative. And then we're going from O to B, which is just the same as B. So that means that we can say that vector B is just the coordinates of point B. And vector minus A is just the negative coordinates of point A. Okay, but don't worry, we are going to do examples of this. Okay, so we're not going to use coordinate diagrams or anything like that, but we'll do the examples, okay? So, not with that, I need a pen bit. So if A is the point, we'll call it 5, 3, and B is the point 7, -1, write the vector AB in component form or column vector form. Okay, so we know that AB is equal to B take away A. Okay, that's something you need to remember. Okay, it's just like a learned fact that you need to remember. You don't get told it, you need to remember it. Okay, so if we have that A is the point 5, 3, then that means that A, the vector, is 5, 3. Okay, so it's easy as that. So B is 7 minus 1. The coordinate B is 7 minus 1, so the vector B is going to be 7 minus 1. Okay, so therefore here, now we get B minus A, so we get 7 minus 1, take away 5, 3. You would keep going underneath, but I don't have any space. So when we're doing these, we subtract the two top coordinates, so we get 7 take away 5, so we get 2, and then we get -1 take away 3, which is -4. So the vector AB is 2 minus 4. Okay, that's how we work finding these vectors. So I'll do a couple more examples and some using 3 dimensions. Okay, it doesn't get more difficult, it just means we've got a Z component instead of just an X and a Y component. Right, so if we do another example, so we've got this time that Q is the point, let's go for 5, 2, -3. And R is the point let's go with 3, 7, -10. Okay, find the vector QR. Okay, so we're going from Q to R. So that's what that's saying, Q to R. So we find that by doing R take away Q. It's always the second letter take away the first one. Okay, so R, we've got our coordinates, so we're going to know it's just the same numbers, but we're writing it in component form rather than as a coordinate. And Q, which is going to be 5, 2, -3. Okay, so we get 3, 7, -10, take away 5, 2, -3. So then again, we're looking at our top numbers first. So we have 3 take away 5, which is -2. We've got 7 take away 2, which is 5. And then we've got -10 take away -3. So that's adding. So it's -10 add 3, which is -7. Okay, and remembering we could also write that if we wanted as -2i plus 5j minus 7k. Okay, that's if they ask you to write it in terms of unit vectors. You do it that way. Okay, there's one last thing that we'll see quite often in terms of position vectors, so I'll do an example of that as well. So we can quite often be given one coordinate and asked to find a second one. Right, so if C is the point, let's go for 4, 7, and vector CD is equal to -2, 8. Calculate the coordinates of point D. Okay, so we're still starting with the same formula. Okay, so we've still got the formula that CD is going to be equal to D take away C. Okay, but what we need to do when we've got one like this is we need to rearrange for the coordinate we need. Okay, so you can always kind of rearrange these formulas. Okay, so we want to get what D is. So like we can go from our coordinate to our vector really easily, we can go backwards as well. So to get D on its own, we need to add C to both sides, so we get CD plus C. Yeah? So CD is -2, 8, and C is 4, 7. So we add those together, and so we get -2 plus 4, which is 2. We get 8 plus 7, which is 15. Okay, so therefore, the coordinate D is equal to 2, 15. Okay, and that works in 3 dimensions as well. Right, so that is everything that we're going to be doing on position vectors. Okay, so we will be moving on to our next new topic.